Right, this is what I want. I'm going to give you $2,000. All right? $2,000 to invest. I want it to double. How long will it take it to double if the interest rate is compounded monthly? I want it to double. So how much do I want at the end? 4,000. And I want it compounded monthly. Which formula am I using? A. Oh, so 4,000, right? Equals 2,000. What?
Are we looking for the percent? Or are we looking for
We're looking for the amount of time. R is 4.75%. Sorry, I didn't put that up here. Okay, so what is my formula here?
1 plus 0.0475
Over 12. 12 T power? Because it's compounded monthly, that's 12 times a year, right? Okay, we're going to divide by 2,000, okay? And the reason I want to do this is, do you all understand when it doubles, this is always better be a 2 here? If it tripled, there always better be a 3 there. So you can kind of almost shortcut it if you need to. Okay, what is this amount?
1 plus 0, that is 1.00.
Is it a long decimal?
Yeah.
Will it go to a fraction?
Yeah.
4819? Well, because this way it's not rounded. And that's much easier than the decimal, isn't it? To the 12 T power.
So that's so close to 100. Yeah.
Well, I've got 0.0475 over 12. That's not very much. Okay, when I have a letter or a variable in my exponent, do you remember we had to solve using logarithms?
Yes.
So, rules are the log of 2 equals 12t log of 4819 over 4800.
We just split it. So we do the ln or the log?
Either one.
Oh, okay, same thing.
Same thing. What?
Okay.
What, Griffin?
We just take exponent, put it outside, and then log both sides.
No. You log both sides, and when you log both sides, the exponent comes out front. Okay, guys, how do I solve for t? Do I divide both sides by 12 log of 4819 over 4800?
Yeah.
And what did you get?
0.000433.
Surely not.
4.3. That can't be right. 14.6214. That's not bad.
That sounds much better.
That's smart.
I don't understand. This happened to me yesterday when I was trying to do the problem too, where I was getting really, really close.
Oh, if the parentheses is 12 log something.
Okay, you divided it by 12 and multiplied it by that log. Your calculator doesn't read that it's divided by that whole thing. Is that what you got?
So how do we actually get it right? Because I keep getting different answers every time I use this.
Well, you divide log 2 by this. 0.62 what? Years. Everybody get that? Does that make sense to you? And I haven't got it.
No, I'm just checking my other ones that I did yesterday.
Oh. All right. Moving along. That's money. Now let's talk about half-life. You all have been in science for how many years? Do you know what half-life is? What is it?
It's half the time that something takes to decay.
No.
Yeah, it's close. Yeah.
That's close. Okay. There are like things in nature.
Yeah, it's half the time where it takes for something to become like non-radiation.
It's actually how long it takes. Like if I have 20 grams of something, it's how long it takes to get to where I have 10 grams. Half-life.
Yeah, that's basically what I meant.
Yeah. All right.
So it can never get zero, right? It's exponentially decayed.
Half-life is equal to ln of 2 over k. Remember when we had our formula y equals y sub o e to the kt? Same k. It's the constant of which things are decaying. All right?
What is decaying? The rate.
So, it's just a constant showing its rate of decay, basically. Okay, if we're talking about SM-151, which is an isotope of samarium. Now, I don't know if you all ever watch Jeopardy,
No.
but the final Jeopardy, the answer the other day was isotope, and I got it. No, it was a word that where the first half meant this and the second half meant this. Huh? Uh-huh.
Why did they like what is?
Because that's what Jeopardy is. All right, so anyway, SM-151 can be modeled by this equation. dy over dt is equal to negative 0.0077y. Okay? Where t is measured in years. Find the half-life. How do I find the half-life? What do I need? I need K. Right?
So we use A equals PRT.
Well, what is A and T? If you think we can use that.
1 and 2.
You're talking about where it doubles.
171.
Can I take the antiderivative? Can we take the antiderivative? It's a differential equation, right? So dy over y equals negative 0.0077 dt. Agreed? 1 over y equals negative 0.0077 t plus c. But because it's not, I don't know the values, and this is a half-life, do not worry about the plus c. I get to this equation.
Hold on.
Shouldn't the left be ln?
Oh, yes, it should, sorry. I was gonna do dy dt and I stopped in the middle. That was my fault. This is ln of y. I was gonna rewrite it as 1y, 1 over y dy, and then I thought, no, I don't need to, so I did half and half. Okay, so what happens here is this must be k.
Well, why do we need to go through all that? Oh, because it could be different.
It could be different. When you take the antiderivative, it could be different. So, how do I find half-life?
ln of 2 over k.
ln of 2 over k. So what is half-life? Griffin, you still haven't found your calculator?
Negative 90.01.
Why is it negative?
Because it's dying.
Because it's decaying.
Or decaying.
Because it's becoming less. So we actually put ln of 2 over negative 0.0077, and that's why that is negative, because it's going down. So my half-life is 90 years. Does that make sense to you? Do not tell me it's negative 90 years. You've got to know what that negative is telling you. Does that make sense to you?
So are we dying every day, or do you get to a point where you reach your peak of your life and then you start to die? I mean, because we're technically dying every day, getting closer to death every day.
But I feel like
But we're not decaying every day
That's true.
until we die. And I would imagine humans have a half-life after they are dead. Now, because don't humans decay? Don't they go away? We start as dust, we end as dust, according to the Bible, right? However, what messes up our half-life?
murder, sin.
Embalming.
Why do we matter if we mess up our
That's not how the Jews do it. They just let the Jews
I didn't say it mattered. I said it had.
Other than Joseph.
Okay, wait. So I'm thinking like,
Oh, I probably missed that last piece, didn't I?
That's right. Harris and Escape.
I paused when I was hearing all Griffin's stories over here. Griffin, your phone is supposed to be off.
my foot is off.
What?
My foot is off.
Your watch is supposed to be off. Yes. Newton's law of cooling. Newton said, when you take something out of the oven, or you take something out of the refrigerator, and you put it on the cabinet, since he went with cooling, he said oven. I set it on the cabinet, the temperature is going to change. How fast it's going to change depends on the temperature of the room. Because a cold room is going to get cool faster. So he came up with this, what he calls, now some people use our y equals y sub o e to the kt. He said he could be more specific if you know all the information. So, Newton's law of cooling is this. T minus T sub s is equal to
If there is a
T sub o minus T sub s e to the negative kt.
It really, it's kind of all over the place.
Let's think about what all these letters stand for. The little t is time. You know what K is. T sub O must be my original temperature. T sub S is your room temperature. and T is your temperature, right?
It's temperature speed.
Like the temperature that the answer is.
Is there a final
Yes.
temperature?
Is there any? Yeah, we should name it TF.
It's just the TV, like,
T is what we're looking for. T sub S is the surrounding temperature, that's why I use S. T sub O is the original. So, knowing that, can I work a hard one? Okay. I'm doing on page 358, number 31.
It's like the reading system thinks it's good stuff.
yeah.
Okay. Suppose that a cup of soup cooled from 90 degrees to 60 degrees in 10 minutes. Okay? 90 degrees to 60 degrees. And by the way, if you notice, that's centigrade. Celsius? Celsius, you like Celsius or centigrade? So, I like Fahrenheit, but it's not.
I don't know.
Okay,
It's like the,
centigrade is another temperature, yeah,
Which four?
no, it means the same thing as Celsius, right?
yeah. In a room whose temperature is 20 degrees. Okay? I want to pretend we're in England, I guess.
America wants to just be better than everybody.
Okay. How much longer would it take the soup to cool to 35 degrees?
So I'm on K.
I've got to find K, correct? I want to go to 35 degrees. So, if I use this, is it true that 60 minus 20 equals 90 minus 20
Oh,
e to the negative k times 10? You all agree with that? Can I solve this for k? I don't know. You might have to Google it. So 40 equals 70 e to the negative kt. So 4/7 equals, negative 10k, right?
yeah.
ln of 4/7 equals negative 10k.
Yeah.
What is k?
0.056.
0.056. And here is kind of deceptive because in the formula I put negative k, but do you understand that k is really negative because it's making it go down?
Yes.
All right. So my question is, how long will it take the soup to cool to 35 degrees? Right? So now I start back over with the formula, don't I? So I have 35 minus 20, right? Equals,
And this formula is T in minutes.
yeah. They use time same as we do. The question here is, do I want to know how far it went from my original temperature of what? 90, or how long it took it to go from my temperature of 60. 60. So now T sub O is 60, right? E to the negative 0.056 T. Right? So 15 equals 40 e to the negative 0.056 T. ln of, isn't this 3/8? Equals negative 0.056 T. What is T? If they agree.
17 more minutes?
17 and a half more minutes.
27. Go to 9. 17.
25, 2 minutes? Okay. Now, part B. Instead of being left to stand in the room, the cup of soup was put at 90 degrees, was put in a freezer whose temperature is negative 15. How long would it take the soup to go from 90 to 35? So I go back to my formula, right? $35 minus what? So plus 15 equals 90 plus 15 e to the 5/6t. Because once I found K, that is just exclusive to that soup. That soup will always cool at that K value. So 50 equals 105 e to negative 0.056 t. Ten over so ln of 10 over 21 equals negative 0.056 t. What is?
13.25.
Okay. In the freezer, it took 13.25 minutes. How long did it take just sitting in the room? 27.5 minutes? Quite a difference, isn't there? About half. Not particularly on time, but like, yeah. All right. Make sense? See if I can